Right, hopefully we are live. So hi everybody and welcome to Lambda Launch for October 2020. This month we've got my co-organizer Alex talking about functional TypeScript. It's basically kind of the lessons that you can learn from FP and how to kind of apply that to, hopefully, a more object-oriented world perhaps. Some lessons you learn from that. So without further ado, take away, Alex. I'm going to vanish for now.
Okay, so hopefully everybody can hear okay, and hopefully this is coming out on YouTube loud and clear. There's always a moment of insecurity on our part, I think, when we first start the broadcast. So I'm going to be talking about, as Connor said, functional TypeScript, and with a little bit of an emphasis on this being for people who maybe not professionally worked in one of the main functional programming languages. And I'll get onto that a little bit in a second. So, and also obviously the context of this, as the title suggests, is that it's functions as a service. So, you know, think Azure Functions or AWS Lambda is the kind of context we're talking about this in. But first of all, a little bit of housekeeping. If you would like to join the Discord, I've just realized that my fingers are pointing in the opposite direction because I'm pointing to my monitor, but it's reversed because of the webcam. If you want to join the Discord, that's where there's usually some lively discussion during the talk and after. We obviously knock around there, and we also entertain ideas for future talks. We are always on the lookout for speakers for interesting functional programming and PLT and FP adjacent topics. So if that interests you, maybe you think you have a topic or talk you might want to do, then please drop into the chat and get in touch with one of the organizers. And during the talk, if you want to ask questions, probably the best place is on YouTube, because we can kind of pop them up and I'll try and answer them as I go. And there's also going to be a little bit of time at the end for any questions you have, any hazing you want to do of my functional programming knowledge. Feel free to do that either as we go or at the end. Okay, so hopefully that's enough time for people to have got that Discord link. And it's been posted in the chat. Sensational. It's in the YouTube chat, so no harm, no foul. Let's get cracking. So I'm a contractor at the moment, and every time functional programming comes up, I kind of appear out of the woodwork in whatever, in sort of, you know, group chats and all sort of stuff. And certainly that's kind of my role in the grand scheme of things. Always has been, really, almost every organization I've worked at, because I ended up doing functional programming quite early in my career, and it's just something that's never got any less interesting. So I'm always looking for opportunities to use FP and FP approaches on projects, because I think genuinely it drives better outcomes. So that's where I'm coming from with this. But perhaps let's turn it around to like who this talk is for. So, you know, as Connor alluded to, I think there's a lot of people that haven't worked in maybe one of like the classic functional programming languages, like a pure FP language like PureScript or Haskell, or a traditional functional, well, let's say a traditional functional language like a Lisp. You know, Clojure is the big one. I'm wearing a Clojure t-shirt because that's the majority of my kind of professional experience in FP is in Clojure. So that's obviously where my horse is stabled. But obviously, if you haven't had that background, or if you work in a shop that's, you know, maybe using sort of Python or Java or JavaScript increasingly, especially on the Node platform, those might not be options for you when starting a new project. And so this talk is a little bit for maybe object-oriented programmers who are curious about functional programming and functional approaches with a sort of soft touch approach. And it's also for people who are in an organization where maybe, you know, just doing a new project in Haskell or Clojure or PureScript is probably not on the cards. However, what I have seen in this project is that making the switch from JavaScript, which was the original language of the project, to TypeScript was an easy sell. And then adopting functional programming practice once in TypeScript was also an easy sell. And so maybe you're a functional programmer and you're working in that environment, and you're thinking about how you would like to bring some of your knowledge and your approaches in, and how to maybe not scare people with monads. And maybe this talk is for you then a little bit as just a kind of like report of what I found, and what I found I could convince people had value. very easily, and what's panned out for us as well on the project. So anyway, and if you're not familiar with functional programming, congratulations, you are being rescued. So there's a thin veneer of structure on this talk. The first part is a little bit of background about the project itself, and why we chose TypeScript. A little bit of how we moved from JavaScript to TypeScript. Some FP concepts that I found I was having to explain to other people on the team, and the ones that had the most value. And then something about the programming style and the general architecture of the project, and how it all fits together there. And then maybe also some drawbacks with the approach we've taken, and some things that I would maybe have liked to have taken further. So that will be in the final section there. So first thing, as I mentioned, I'm a contractor. I'm working at Co-op Group on a project called Cooperate. Cooperate is a fun AWS Lambda project that looks a little bit like this. I'm sure you've instantly paused this and you're straight away like, right, I get you. I get what you're talking about, Alex. Fantastic. Let's move on. But I'll give you a little bit of, I'll explain a little bit what's going on here. So there's like a public part of the site. There's an admin section. There's a utilities section, things like migrations, all that kind of stuff. Some image and file handling, some private utilities. And then there's two main parts of the site: an events listing and sort of matching for essentials and sort of groceries and whatnot, which was part of the coronavirus response. And we'll see why that was important in a little bit. But the long and short of it is, you, again, probably looking at it and just going like, yeah, okay, fine. The takeaway is that it's a big serverless project, and it had to be done quickly. So the alpha of the project that was already built before myself and a couple of other folks joined was a events platform. And then we were sort of brought in to bring on this coronavirus response part. Because then the lockdowns lessened in severity, sort of come June, July, we actually ended up pivoting back, and then had to sort of like flexibly be able to bring online new features quite quickly in a quite different domain. And that's, I think, where particularly the kind of serverless paradigm actually helped us really well, because we weren't, from a cost perspective, paying for usage that wasn't happening, but also you can deploy and test things very, very, very quickly. But that's not really about FPs. We won't talk about that a huge amount, but it's an interesting thing, I think. Yeah, so we pivoted there, pivoted back, agile development, happy days. It was written in JavaScript originally. 3 of us came on the project. Our common language was JavaScript, because it was Clojure, Go, and Node. And so it was like, okay, well, between the 3 of us, the one we can agree on is Node. And it had the usual pain points, double with the fact that we had to get the first version of the project out in 7 days. Which meant that so I think this particular meme literally came from our Slack chat on launch day. We were just genuinely looking at the stuff that we had out in production, and we were like, there are goodness knows how many problems with this, because primarily, I mean, really with Node and with JavaScript, it's usually handling of nulls, isn't it, and undefines and that sort of stuff. But a lot of our pain was really coming down to the weakly typed nature of JavaScript. And as my t-shirt attests, like I'm not scared of dynamic programming, but I'm used to working in a strongly typed dynamic language, and particularly the bugs we were seeing around effectively weakly typed language were really, especially when you've got me coming from a Clojure background, somebody else coming from a Go background, the frustration was really, really acute, because you're like, these are problems that we just normally wouldn't have with our chosen language. Which leads us to TypeScript, right? Strongly typed, great interrupt story with JavaScript, and types aren't objects. You can use types very, very fluently. You can, go all the way to ADTs and higher kind of types and all that fun stuff as well if you want, as well as doing sort of like your classic sort of parametric type polymorphism. The same way you would do sort of multi-methods in Clojure, you can do with interfaces and discriminated unions and that sort of stuff. So like, a powerful type system, a quite expressive type system. And that seemed like a good structure. We made the case for it. People were interested in seeing how we got on with it. So that was great. And it's worked so well so far for the project. So we scaled out to 25 1,000 lines of code, maybe a bit more. 52 functions, costs us 25 pence per month when there's not lots of usage. It costs a little bit more otherwise, but it's still not very expensive because it's Node. It runs so quickly and you're paying per like millisecond of use. So most of our functions are hitting Postgres, well, Amazon Aurora, and being done, you know, in such a blink of an eye that they just don't cost as much money, to be perfectly honest. So that's pretty cool. We're pretty happy with it. So project setup, like I said, we moved from JavaScript to TypeScript. How do we do that? Okay, well, yeah, that's pretty much it. I mean, like, honestly, not facetiously, that's pretty much what you have to do. For our point of view, we're using the serverless framework, and we put in a build plugin, and then we added a TS config, and we already had strict null checks in our, enabled strict null checks. And we already had Novar enabled in our ESLint. So that actually made a lot of our bugs go away straight away because the code didn't compile for starters. And we spent about 3 days sort of fixing it and adding the correct function signatures and stuff. And that took about 3 days, and that solved that problem. What we'd found with, because there's Novar obviously in your ESLint, should on paper like eliminate a lot of the problems of like mutability knocking around and kicking over your party cake. But what we found was that with JavaScript particularly, you've got so many client libraries that have other ideas about immutability that Novar didn't get us very far, and that's equally a problem that carried over to TypeScript to some degree. So this was us in JavaScript land, having a bit of a Nicky Cage freak out. And then we moved over to TypeScript, and a lot of those problems went away pretty quickly, and we were pretty happy. Except that when things did go wrong, they went wrong in spicier and more esoteric ways. This is a real error that we had in production. So TypeScript's not a silver bullet, is basically what I'm saying. It's very easy to move over from JavaScript to TypeScript, but with that comes the fact that you're not getting a huge amount of abstraction over the core JavaScript platform, and that can lead to problems, especially if you, like us, were porting code that was already in production. So there's an element of, okay, you know, to what extent do we go back and enforce types over everything, or, you know, like how pragmatic are we going to be about edges of the system and that sort of thing. So and the other, you know, very crucial thing is that there's no runtime type checking. So you know, it compiles down to JavaScript and then it runs as JavaScript. And if you're used to, well, if you're used to runtime type checking, or if you're used to a language like Clojure, I know I bang on about it, but one where using schemas and runtime type checking is a very, very common best practice, you kind of very frustrated. I found it incredibly frustrating how we were able to catch a lot of errors at development time, only for userland errors to crop up at runtime, which we hadn't anticipated. And, you know, obviously there are ways you can get around that, or at least kind of mitigate that with sort of generative testing and whatnot. But it's still a frustrating experience because once you've eliminated the easy category of errors, this is maybe a testament a little bit to TypeScript being quite good, because once you've eliminated the easy errors, you're only going to end up with the painful ones. And we certainly end up with some painful ones. So, and we also ended up with a little bit with this kind of feeling about it. But so anyway, a mixed bag, but better than JavaScript is the takeaway. And we're pretty happy with it. And we still absolutely would not go back. And if I was going to start a new JavaScript project tomorrow, you know, TypeScript is a pretty, well, if I wasn't allowed to use PureScript or ClojureScript, TypeScript is a pretty good option. So what FP concepts were we using? Well, I mean, 10,000 feet, the things that we really, really wanted to enforce were this: no objects, no mutable state, map and reduce. Now, if you're in an O, like, use map and reduce as kind of like your basic interface for pretty much everything, right? So if you're working in an OO shop, this is, you know, it's a little bit of a foreign idea. But, you know, especially for those of us that worked in a functional environment, it's very, very straightforward, right? Isn't it? And crucially, you can explain it to other members of your team, and you can explain it to other people, like at its core, like where the value is, very, very easily. And this is an actual diagram I use for that, where you're saying, okay, we're using AWS Lambda. These are very, very small services, microservices, if you like. And it's just data in, data out, set of functions, happy days, right? And then, we've got side effects, which I've deliberately made this slide really complicated because side effects are where all the drama happens. But the crucial thing is, like, we've got databases, right? So side effects do complicate the picture. But even in that state, we can still model things very, very simply and get a lot of value out of, really basic functional approach, where we're just saying, okay, well, hang on, let's just bring it back to just data and functions. Ignore types for a second, just data and functions, and how much value can we get out of just that level of simplifying down our domain and our programming style and whatnot. And this is kind of it for a serverless for a function or a suite of functions. It's just an HTTP request on the way in. That's just data, right? You serialize it, deserialize it, and it's just JSON to some hash maps or whatever. And then just a series of transformations, most of which are non-side effective, most of which are data in, data out. They're referentially transparent, they're pure, and they're deterministic. The only bit that isn't is, a write to the database. And then, you're just serializing stuff back out to send to your web front end or whatever other dependent services are talking to your API or whatever it is. The only caveat I think we found really early on is that AWS want you to declare database connections as globals outside of your handlers, so that they're pooled. So that the connections aren't reaped, and then if there's not a cold start, the connection can be reused because it's in global state in the container. And that's great from giving you a slight performance benefit, but obviously it means that locally, if you run that function, your connection is just left open and it just hangs. So that's really bad. And so we completely ignored AWS best practice and closed over our database connections and used sort of a dependency injection style model where we were pushing them in via a system map. And it means that you can, and I'll talk about this probably ad nauseum in a minute, but it means that you can actually just treat your handler functions like any side effecting function. So yeah, like I said, the core of the value here is actions and data, and that's really easy to explain to other people and stakeholders and whatnot, even if they've not worked in a functional environment, because you can bring it back to unit testing, etc., very, very quickly. So it's just, it's actions and data, transforming data, and then you don't have to understand the primacy of data or the primacy of composition in sort of structuring a program to see that there's a testing advantage there. So that was the way that we were primarily sort of like explaining this programming style when we were talking to other teams and other people. It's just all about composition, right? Passing around data, composing actions, referential transparency is determinism. And determinism, again, is another thing you can point to when you're trying to explain to colleagues what the value of this thing is like, repeatable results in terms of unit tests. And unit testing is this thing, especially with TDD and object-oriented land, that is kind of on a pedestal, and people want to, are prepared to devote a lot of time and effort to thinking about. So you can tie into that conversation when you're talking about these kind of core functional programming concepts, like referential transparency. And this is just a meme that I put in because it's been like a few slides since there was a meme. So, I pressed up. Let's press down. So now, right, it's time to talk a little bit about what I call the functional architecture, which is not at all what the definition is for the architects. And also like then, some more precise examples of this. So functional architecture for me, right, is basically just like, is your project one big program, like conceptually? So AWS Lambda, obviously, they're all sort of these microservices, nano services, whatever. Can you treat them as if they're just side effecting functions? That's what it sort of boils down to. It's all about testability, and it's all about kind of both in the small and the large, taking the things that we know about composition and passing around data and serializing and deserializing and contracts and making that kind of real from the perspective of a larger program that actually crosses system boundaries potentially. So yeah, it's just all one big program. It's big brain time. And I know everybody's gone, yeah, every single architecture is just one big program, Alex. That's literally how it works. Okay, all right. I'll give you that. I'll give you that. Fair enough. But bear with me. Okay, so let's talk about some of the individual bits. So contracts. This is a thing that if you're not used to doing like runtime contracts and stuff as part of your general style of like team discipline or whatever, there's obviously a huge amount of value in it, and TypeScript doesn't runtime check, so you're going to catch a lot of bugs. And it also helps you with knowing that your inputs and outputs are compatible to some extent, because although obviously you have types to actually validate whether or not these things are compatible and whether they compose, the reality is that because it's not checked at runtime, if you're doing any serialization and deserialization, which when most of your functions like ours are 40 lines long, a big chunk of the work of every function is going to be serialization, deserialization, and then a little bit of work in the middle. If either of those serialization or deserialization steps at runtime doesn't do what you expect, then your types are not necessarily going to tell you what's compatible. But so the key things that we're doing to actually check these things are, other than contracts, to check these things are actually compatible and composable using interfaces, enums, and sort of simple types. By that, I mean sort of just scalar and array type things. And we're using them to validate pipelines of function IO, right? Again, this is not new for any functional programmers in the room or the virtual room. It's all about composition. And I know I reuse this meme. So most of our types are pretty simple. They're just hash maps of things, because again, we're talking over an API, so it's JSON, and we're just going to deserialize that and say, okay, is it one of a thing or is it a collection of that thing? And there was an emoji for cyclists, so that was the one I picked, also because I cycle quite a bit. And we found that we didn't really need to, when we were composing together these changes of things, in the first few months anyway, we didn't really need to think about monads. It didn't really occur to us that this was a thing that would be valuable. And also, you know, I don't have to explain stuff like this to people that aren't, you know, to be fair, actually, I put this in deliberately because I don't understand it and I've done a bit of Haskell. But I'm sure the Haskell folks are probably looking at that and going, yes, that's just a regular post on the Haskell Reddit. You are an idiot. Guilty as charged. So anyway, that's my reaction. I don't want other people who I'm trying to convince that these approaches have value to have that reaction. So we're not trying to scare anybody. However, I will stop and say, like, I don't want this to feel like I'm just going to like have a go at monads or have a go at Haskell or have a go at you know, sort of algebraic data types or using typed FP, because despite working in Clojure, like I've worked on projects where we used sort of the CATS library and, like, you know, manifold deferreds and manifold streams, and especially for asynchronous tasks, monads are an incredible tool for giving you actual hard guarantees over a thing and a reusable context that's reusable in a way that promises just aren't. And anybody who's ever worked for a long period of time in JavaScript is going to have experienced that problem where you move into a promise or a thenable, and once you're within that context, you can't break out of it and you can't fluently compose different abstractions. And this is what's interesting about await. It's like async await in more recent JavaScript, is it solves the problem by going, actually forget about that entire API that we've had you using for years and just treat it like it's imperative code. And that's fine. And that's effectively the existence of async await is why we didn't have to think about monads. If we did, and we'd had to think about them more as more of a fundamental part of our architecture, like it would be either use monads or use thenables, promises, then it would be an easy decision. It would be a very easy decision to say, okay, we need something better than promises that allows us to fluently compose in a way that we're not able to. And like I say, Haskell worked this out in 1996, and we're still in JavaScript in 2020 going like, oh, this stuff is so hard to work with. It's so hard to work with. So other tools that we found helpful for adopting more functional style, initially Lodash, because it was in the build from day one. And again, if you're working in a JavaScript code base, Lodash is already there. It has loads of functional tools. A lot of the core API is immutable by default, caveat to come, obviously. And it's like, I don't know where you work, whether there's a thing where you have to actually justify a library being added to the build, but you're probably going to have to justify the style of the code you write. So maybe Lodash is already there and it's the path of least resistance. However, Ramda's better. It's just better for functional programming. And you can do all the fancy fun stuff like point-free programming. And it's just immutable by default and better. And so like we've gradually ripped out Lodash and moved in the direction of Ramda. And that's been really, really good. It's been a really good experience, great library. But if we started again tomorrow, would we just use FPTS and IOTS? So FPTS is the typed functional programming library, the one that's got the most mindshare in the community, I think, for TypeScript. And IOTS gives you some tools for doing sophisticated, well, kind of like more fluent runtime type checking based on your types, right? And that is my chief complaint with a lot of the sort of, as we got deeper into sort of making sure that everything was typed and everything had the correct signatures and we were passing around things and composing them in such and such a way, the lack of runtime checking was the thing that was stressing me out the most. And IOTS takes away a lot of that issue, but migrating over to it, if you've not gone that way from the outset, it is a bit of a pain. And so if we started again tomorrow, that's probably where a lot of the value would lie. Yeah, so essentially, essential functional programming stuff like mapping over stuff rather using for loops and stuff. Luckily, the JavaScript community has gone this way already. And so, nobody's complaining about the style of using things that are going to take arguments that are these things rather than calling methods on arrays and collections, which is still kind of mad to me. But Lodash has its problems, right? It mutates state and all the sorts of things. So this is why you should just use Ramda. If you're just looking at a way of doing like soft touch functional programming in TypeScript, in JavaScript, Ramda is pretty decent, and most of it's immutable, so that's cool. And again, like functions, not methods. So like taking it back to kind of like the core ideas that were very easy for us to sell in as a code style, as a style that we could hand over to people and they could maintain, is this sort of stuff, right? It's functions, not methods. It's closing over things like database connections, so that we can treat, units of code as atomic. And I'm now going to show you some examples from very early doors in the project. And I've actually looked at this about an hour ago and I realized how bad some of this is. So I apologize in advance. And don't worry, it has all been refactored. It's much better now. But anyway, so the long and short of this one is like this is effectively a real handler for us. It's quite a simple one. It's about 25 lines of code. That's quite typical for a lot of our handlers, because you can see there basically on line 26, there's a transformation function that's doing the deserialization effectively, and doing the sort of the data transformation. It's the deterministic part of the chain. There's a database call on somewhere. Oh yeah, 16. Oh yeah, because this is a get function. So this is probably actually a really bad example, because if you had an update or a create, you'd actually see a chain of functions organized like a pipe. But hey, what you going to do? This is the example I've got. But you can see there's basically only a couple of different things happening there. There's a side effecting call to the database, and there's some data transformation on the way in, and there's some data transformation on the way out. And the whole thing is like quite small and compact. And all of those individual functions, aside from the side effecting one, which obviously requires you to spin up a database to test it, can be unit tested in isolation, and they can be unit tested together. And that entire function, which you can see that the the database call is like brought in there, and then it's closed up at the end. It should be closed up in a finally, but it's not, because we wrote this in a hurry like idiots apparently. All of this can be tested in isolation because it manages its own state, closes its own database connection. So you could just call this function in an await as a unit test, and it would work. And then, the other thing is it's an any type. I've just noticed that. So it shouldn't be an any type. It should be a response with this interface on line 46. So this is most of the stuff we're passing around as hash maps because we're crossing that system boundary so often. So we're using things like interfaces like this to validate that at development time. And then we have some JSON schemas to validate it at runtime. So that's the contract checking that I was talking about. And we're also able to use those at different points because we've got those in sync with each other, so that as long as you call it in the right place in the transformation pipeline, you can do it at various times, basically. So it's quite reasonable. That probably doesn't make a lot of sense to see our code base, but never mind. And then so this is like quite a typical kind of simple interface for a user, and then a transformation function that's just doing some destructuring, and then I guess quite typically you'd have like some date times or something, and you'd be doing some date wrangling in your transformation function. So, but not here because this is just the smallest example I could fit on screen. And then this is what I was talking about with unit testing. So unit testing, you can go down to line 100 and you can see that the handler function is being tested exactly as if it was a regular database function, like that is a side effecting function that takes some data in and returns some data out. So obviously it's got side effects, can't guarantee that happy things are going to happen, can't guarantee it's not going to hang, etc., etc., etc. But you can at least test it like in a really straightforward way. And this means that you pretty much never have to run the local stack either, which is pretty cool when you're developing. It means that our time to live on a bug is like half a day. It's pretty quick. And it's fuzzy. Sorry about that. I don't know how good quality the stream is. I should have made it, but I guess it's actually as big as I can make it. But sorry about that. If it's a bit unclear, the takeaway here is not really to worry about the code, but just to take away that you can test the function like it's a regular database function in a JavaScript or TypeScript application. That's the main thing. So let's bring it all back together. Like where is that? Because what we've been talking about here is like not how to do functional programming, but like maybe where is the value in it that we've been able to express in a shop that's not a functional shop, that's not using functional languages, and without getting closed down. So making sure that everything's just a pipeline of functions, making sure that everything pure is testable in isolation or composed. These are obvious things in a kind of functional world, but even if you're doing kind of like functional JavaScript, like the programming style still doesn't take into account a lot of this stuff as far as I can tell. Unit testing, the function isolation, testing composition and side effects, and the handler test. And the handler test is the thing that I don't see other people doing. I don't see other people testing API endpoints in the context of a large app, 50, 60 functions, as if they were just regular functions. And that it like has a huge impact on our speed as a development team. It's really important. And so the summary is like where we're getting the value from, like data first, that's an FP concept. If anything, it's a kind of, I guess, a Lispy thing. Small composed functions, it's just what you do, isn't it? Pure function with validated IO, that's TypeScript's doing all the heavy lifting on that. And like I say, there are a load more tools you could use, in a TypeScript project if you started day one and you brought in things like IOTS, etc., etc. And limiting side effects to only ever being in the handlers. Like you have individual functions that maybe do a side effect, like a database function, but they do just that one thing, like really small. All of our database functions are like 3 lines long. They literally just like run the query. That's it. No funny stuff. And it means that we're able to do that small granular unit testing, and then that big like chain of side effecting tests when we're doing handler tests. And then the flip of the coin is that what we've seen is that we've got increasingly railway style over time. So we're not using either monads or option monads, but the style of our code looks like we're sort of trying to do something like an either monad without having an either monad. And that is obviously a little bit of a code smell, right? Because you're looking at it and you're going, okay, well, so the only reason we're not doing this is because our functions are so small, our handlers, that is, they're like 30 lines or whatever. And we know we have to sort of have some basic like node level, platform level error handling. So that drove us down the path of not being bothered with sort of error handling in a monadic way, because we were like, well, we're going to have to wrap everything in a try-catch finally anyway. But as the complexity of some bits have grown, it has driven us down the question. So if you have a really good example would be if you have an endpoint that might be called by somebody who's a logged in user and somebody who's accessing it publicly, or somebody who's a logged in user and somebody who's a moderator or an admin or a member of the owning organization. You might have 3 pieces of code that look very, very similar, all effectively return an API response, but all of which could be treated as an atomic piece of code in a chain of monadic ethers. And instead, you're having to treat it as if it's sort of like a composed function call of an API handler. And that is a code smell, because you're like, okay, well, this should probably be a chain of ethers that happen to be returning responses. So yeah, if you could get, if you know your code base is going to get sufficiently complicated and your handlers are not going to be 30 lines long and they're going to be bigger, then there's a whole bunch of stuff that you could bring in from FPTS. And obviously I've said before that I'm a big fan of using a monadic asynchronous container rather than the native promise stuff, because it's not very good in my opinion. So, and task-either is a really good wrapper for that stuff. And FPTS contrib gives you a do with binding and everything. And it means you can do these really neat transformations when you're having to do that sort of work over asynchronous operations, which obviously is all the time in Node. So that's my caveat, is like, I think our code style is a little bit driven by knowing we have to hand it over at some point to people that may be unfamiliar with some of this stuff and needing to explain it, as well as needing to obviously bring people on the project in the first place. But if we started again tomorrow, we'd probably lean much more heavily on some of the more, some of the kind of more monadic stuff, I think. And that's it. So I don't know if there's any questions or anything. Okay, I'll give it a few more seconds. If there's nothing else, then I think we can probably call that a wrap.
I think James said he had a question, but I'm not sure what it was. James?
I've put it on YouTube, so it'll come up in just a second. We might as well. I mean, I've typed the damn thing out at this stage. Come on.
This is the pearls of asynchronous programming, I guess.
Yeah, it's absolutely. I'll just say it because there it is. I was going to ask about serverless framework basically, because is it any good? Just you mentioned it, and I think it's an interesting thing. Appreciate it's not very FPE, but yeah.
Right. No, I mean, so I would say I have mixed feelings on the serverless framework. The serverless framework is very, very good for getting started, and it has some great plugins. Like SLS Offline is incredibly good for if you've got like front-end devs who need to run the project. They can treat it like a regular web application that's running in like a jar, or however you would normally package and run compile and run a web app locally. They can just treat this suite of functions that will be running somewhere on AWS Lambda as a local application, as if it was Ruby on Rails, which is brilliant. And you get that almost for free. The downside is that although it's kind of packaged as this shim across all of the cloud providers, it works best with AWS. So, which is probably fine. I mean, it's very rare that any of us actually have to switch cloud providers. But the flip side of that is that it is just a thin shim over CloudFormation, and CloudFormation is rubbish. So you end up having to increasingly sort of have a Terraform pre-task or your deployment management tool of choice, then run the serverless tool, the serverless deployment thing. And then quite often, if that doesn't work because CloudFormation goes wrong or something like that, then potentially run a second task. And it took us sort of 2 to 3 months. Our first month was super smooth. Then our deployments got a little bit more complicated. Then our next 2 months were very unsmooth. And then it took us sort of like that almost 3-month period to get it stabilized and get it sort of really smooth. And now we have like a really nice blue-green deployment set up, and it's great. But I think the competing needs of the way we had to do platform infrastructure and the way serverless kind of wants to be used meant that there was a period of time where it wasn't ideal.
Mm-hmm.
But all in all, where we starting again tomorrow, we would use serverless. That's just, I think, a given. Just especially just the packaging for the front end devs and everything. It just takes that problem away. Mm-hmm. Do we use serverless components? No, we don't. I don't think so anyway. What is a serverless component in this context?
I'll pull this one up as well. How have you found the types for Ramda?
It hasn't been a problem for us. I'm not really sure. You might have to expand on that question.
Okay. I'll pull this one up. What patterns of reuse did you use? Reuse did you use or learn? Yeah.
So this is quite an interesting one. I think the thing that we learned, I think the thing that we realized quite early on was that we were seeing monads everywhere. And I think I touched on this a couple of times, where because our functions are so small and because some of our errors are user land, and they're just out of bounds errors, we have to be wrapping everything in try catch finally, like node level, platform level error handling. And I think the fact that our errors were user land and were things we couldn't anticipate and things that were not caught by the types, because they were to do with how things were deserialized or you know, a timeout from some third-party service or something, meant that we sat on the fence about using monads to encapsulate, you know, operating over a chain of things where they're asynchronous and they're talking to a database, and also the database is in the context, perhaps longer than we would have done. And so an interesting aside to that is at the moment we are spiking using task ethers and the FPTS contrib do to tidy up some of our more complicated functions, which are like 60 lines of code rather than 40 lines of code. I mean, these are nano services at the end of the day, but I think the reuse was that everything composed really neatly on the whole. Like we had quite a lot of discipline about like argument order as well. Like if you're passing around a connection, it's always your first argument. If you're passing around a connection, make sure it's typed. So at development time, if something goes wrong, it just won't compile. And that solved us a lot of problems. And like the thing I said about the other pattern of reuse that's very common was the thing I said about scalar things versus collections, because Ramda is really, really good at that. It's quite Lispy in that regard, where it's sort of like, are you merging hash maps or messing around with collections of things? And that the TypeScript type system worked really nicely with that. And we were able to reuse lots of code and lots of like our list processing utilities and blah, 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 blah. But yeah, and so yeah, lots of that basic stuff around the way we're using Ramda, the way we're using our types was the main reuse. And the thing we learned was that maybe we should use monads, is my short answer. That wasn't a short answer.
I'll pull this one up because it's good. There's this one about kind of the types of meaning is useful. And then I think there was a follow-up one, which I'll pull the follow-up one because it's also useful. Where is it? I think it's this one here about types didn't always follow the transformations within a map.
Okay. So that is still a little bit the case. We have in a couple of places had to do stuff like where you've done a transformation on a thing, and then after it you just say transformed thing : array of the thing that I thought it was going to be, so that the compiler goes, no, hang on, this is definitely wrong. A little bit that, but it is. I think I kind of know the period you're talking about, but it's not as bad as it was. But again, sometimes, and also we have sometimes had super weird, like we've had a really weird persistent bug with one particular part of the code base where it's not even a bug, but just the type checker lets you compile the code and run tests locally, and then when you push it to CI, it goes, hang on a minute, this doesn't compile, and just throws an error. So again, TypeScript quite often has had our back in the end, but that particular bug we tracked down to external library with one of the projects we were working on, and it was a similar thing to what you're describing. And it was just like sometimes TypeScript went, oh, I've inferred that this is the right thing and your code is wrong, and sometimes it went, now I'll compile. So that's all part and parcel of the problem of it being a thin shim over JavaScript, I think.
Absolutely. Okay, I think if you want any more questions on YouTube, please get them in now, because I think soon we'll finish up. Do you want to pull the Discord link back up again, just for yeah, I can always post it again if necessary.
Yes. Let me just switch. I need to switch over to the monitor and go.
Yep. So yeah, any more questions, please chuck them in now. Otherwise, we'll probably move over to Discord, where all of us, I'm there, Tom will be there, Alex will be there. But yeah, I don't think there's anything else going to come along.
And to Richard's point, yes. Okay, I think I know what you're talking about. I didn't realize those were called components. We will probably spike something out with them when they've stabilized a little bit. But yeah, 90% of our pain is with CloudFormation stacks, and we've shuffled quite a bit of that pain over to using additional plugins and using Terraform to manage that state. And now we have a very, very stable deployment. Like I say, it's blue-green. So we just deploy a stack over here, and it's completely independent of what we're running. So we don't have to worry about AWS stacks going wrong or any of that stuff anymore. But yeah, anything that can decrease the pain of CloudFormation stacks is worth doing, would be a final lesson that I would implore you all to take away.
Absolutely. All right. Okay. Cool. I think we should call it now. Thank you very much, Alex. It was really useful. Yeah. I will just let me see if I can just grab the Discord link for one final post of it. Got that. There we go. Right. Yep, we will finish now. Thank you very much, and we'll see everybody on Discord. Cool.
And remember, we're always on the lookout for speakers. So if you have an idea for a talk, or would like to, maybe you have half an idea for a talk, and you're wondering whether it's a good idea, we're in the Discord. You can ask one of us organizers, and we can help you develop an idea. But yeah, we would love to have more people talking, especially in these strange times. It's good to feel like there's a programming community out there in the ether. So please do get involved if you have something in mind.
Mm-hmm. Yeah, absolutely. Cool. All right, let's move over to Discord. Thanks, everybody.